Hi all, welcome to lecture 2 of module 4 in database management system. Today we are going to see the topics equivalence of sets of functional dependencies, and second one is minimal cover. So equivalence, so first we are going to see how two set of functional dependencies are going to be equivalent. Okay, in the last video lecture we have seen how to compute the closure of attribute, closure of a particular attribute a plus or b plus. Okay, അത് നമ്മൾ compute ചെയ്തു. So using that closure, we are applying that closure, that rules of closure property. We are actually computing the equivalence of functional dependency. So what is the equivalence of set of functional dependency? So equivalence of set of functional dependencies. So we are having, suppose we are having two functional dependency sets E and F. So E is one functional dependency set. So here we are having 1, 2, 3, 4. E is having 4 functional dependencies, and F, the set F is having 2 functional dependencies. Okay, so our task is to compute, our task is to find out whether E is equivalent to F. Okay, whether E is equivalent to F, that is our task, whether E is equivalent to F, that is our task. In order to find this E is equivalent to F, we need to find out two things. We need to find out whether E covers F and F covers E. So what is E covers F and F covers E, that we will discuss now. Clear? So the definition says that a set of functional dependency E and F is equivalent. Okay, so this set of functional dependency E and F are equivalent if the condition is E covers F and F covers E. Both this must be satisfied. E covers F as well as F covers E. So what is E covers F? E covers F means that the functional dependency in if F can be inferred from E. That means that E covers F means that we are having, we will look at the second part, second set. E covers F means we will take the functional dependencies of F. Okay, and we will take each functional dependencies of F and we will try to derive these functional dependencies from E. Okay, so that is called E covers F. E covers F means that all functional dependencies of F can be inferred from E. Okay, that can be derived or inferred from E. Clear? So we take each functional dependencies of F and we will try to infer these functional dependencies from E. Okay, how to do that? That we will discuss soon. Now about F covers E. What is F covers me? F covers E. Okay, the opposite to this is F covers E. F covers E means that all the functional dependency in E can be inferred from F. Okay, so each of these functional dependencies of E can be derived or inferred from this F. That is called F covers E. അപ്പോൾ എപ്പോഴും ഓർക്കുക E covers F എന്ന് പറയുമ്പോഴത്തേക്കും നമ്മൾ രണ്ടാമത്തെ എഫിൻ്റെ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസിയാണ് നമ്മൾ E വെച്ച് ഡിറൈവ് ചെയ്യാൻ നോക്കുന്നത്. അതുപോലെ F covers E എന്ന് പറയുമ്പോഴത്തേക്കും Eയുടെ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസീസിനെയാണ് നമ്മൾ F വെച്ച് ഡിറൈവ് ചെയ്യാൻ നോക്കുന്നത്. ഓക്കെ, so E covers F, it also means that whether E is covering all the functional dependencies of F. അങ്ങനെയും പറയാം. Okay, E covers F means that whether E is covering all the functional dependencies of F. Similarly, F covers E means that whether F is covering all the functional dependencies of E. Clear? So now we can compute how to compute this E covers F or F covers E. That is what we are going to see now. So computing F covers E or E covers F, whatever it is. So here I am going to compute F covers E. So F covers E compute cheyanayittu what we have to do is, what we are having, so they have given two set of functional dependencies F and E. So please remember that this F and E is not a single functional dependency, it is having sets of functional dependencies. അതിനകത്ത് ഒരുപാട് functional dependencies ഉണ്ട് കേട്ടോ. 1, 2, this is one functional dependency, this is another one, this is another one. So what do you mean by functional dependency? I have discussed in the previous session. Functional dependency is nothing but the relationship between two or more attributes in a relation, or relationship between two attributes, two or more relationship between two or more attributes in a relation. That is called what? That is called functional dependency. Clear? So here we are going to compute F covers E. Okay, F covers E. So what I have to do is I have to take each of the functional dependencies of E. Okay, ഇതിൽ ഏതൊക്കെ functional dependencies ഉണ്ട്? C implies D, D implies E. Or we can also say that C determines D, D determines E. Okay, so the first task is we will compute the closure of this LHS. അതായത് we will compute the closure of C plus and D plus. Okay, with respect to F. F നമ്മൾ റെഫറൻസ് ചെയ്ത് വെച്ചിട്ട് with respect to F we will compute the closure of C plus and D plus. And we will confirm that whether C plus, the answer to this C plus contains this D and answer to this D plus contains E. If it's so, then we can say that F covers E. Okay, we will see the detailed example in the next slide. Okay, before that we will go to the explanation. We can determine whether F covers E by calculating X closure or X plus. X plus means X closure with respect to F for each functional dependency X implies Y or X determines Y in E. അതായത് ഇയിലുള്ള functional dependency ആണ് X determines Y. Okay, so the functional dependency in E is actually X determines Y. In that what we do? We will find the closure of X. We will find the closure of X, that is X plus. Okay, the answer to that, how to compute the closure of X, that is done with respect to our functional dependency set F. If that closure of X contains Y, if the closure of X contains this or includes this Y, it means that it successfully F covers E. Okay, and then checking whether X plus includes the attribute Y. This is how we compute F covers E. Okay, ഇപ്പോൾ അത് പറയുമ്പോഴത്തേക്ക് നിങ്ങൾക്ക് മനസ്സിലാവില്ല. I will explain it with an example. Okay, so this is two set of functional dependencies. So F and E. F contains this two functional dependencies, that is A to BC and D to AE, and E contains A to B, AB to C, D to AC, D to E. Okay, we can also say that A determines B, AB determines C, D determines AC, D determines E. അങ്ങനെയും പറയാം. Okay, so I want to check whether E and F are equivalent. I want to check whether E equivalent F എന്നുള്ളത് ചെക്ക് ചെയ്യണം. Okay, so solution is if E equivalent F is not equal to, it is equivalent. So we will write three lines. Okay, draw three lines. So if E is equivalent to F, then we have to check what we have to check. We have to check two conditions. What is the condition? First we have to check whether E covers F and F covers E. ഇത് രണ്ടും compute ചെയ്യണം. E covers F and F covers E. So first I am going to compute E covers F. Okay, so E covers F. I am going to compute E covers F. So given, I am again writing these two functional dependency sets again. Okay, I am going to repeat here. So E equal to A determines B, AB determines C, D determines AC, D determines E. F equal to A determines BC, D determines AE. Okay, so E covers F means I will take each and every functional dependencies of F. Okay, F ഇലുള്ള functional dependency ഏതാണ്? First one is A. Okay, so what I have to do is I will take the closure of A, that is A plus. E left LHS ന്റെ closure എടുക്കും, that is A plus with respect to E. സാധാരണ നമ്മൾ ക്ലോഷർ എടുക്കുമ്പോൾ we will looking into this set. Now here we are going to look into this set and derive. Okay, so A plus A closure. So the first answer will be what? A closure. The first answer will be A itself. Okay, why A itself? Due to our reflexive property. Reflexive property വഴി എയുടെ ക്ലോഷർ എന്ന് പറയുമ്പോഴത്തേക്കും ഫസ്റ്റ് വാല്യൂ വിൽ ബി എ ഇറ്റ് സെൽഫ്. ഓക്കെ, സോ എയുടെ ക്ലോഷർ കണ്ടുപിടിക്കുമ്പോൾ the first value will be the A itself. Okay. Now we will look into this functional dependency set. Okay, we are deriving computing the closure with respect to E. Okay. Now we will check whether A determines B. Okay, so A can derive B. So next value will be B. Okay, next value will be B. Clear? Now B determines okay, B determines but we are having AB determines C. We are having AB here. So AB determines C. Okay, so we can write here C. We can write C here. Okay, so A, B, C is the closure of A with respect to E. A, B, C. Clear? Now we have to check whether this A, B, C contains the RHS of A. A determines B, C. B, C is contained in this closure. This B, C is contained in this closure. So that means that this A closure includes B and C. So this is satisfied. Okay, but E covers F and fully satisfied. We have to check both the functional dependencies. We have only checked A determine BC. Now we have to check D determine AE. Okay, try to check D determine AE. Okay, so how to do that? D determine AE. D determine AE. D determine AE. So I will compute the closure of D. But D closure. So what is D closure? Okay, what is D closure? You check. D closure. We are referring this functional dependency set. So what will be the first closure value? D closure, the first value in the one. Due to reflexive property, the closure of D is, the first value is D itself. Okay. Now what will be the second value? You check anything is starting with the D. Yes, D determine AC. D determine AC. So we can write A and C here. A, C. Okay. Now anything is starting with A. Anything is starting with A here. Yes, A determines B. So we can also write B here. Okay. B here. B here. Clear? So anything is starting with C. Anything is starting with C? No, nothing is starting with C. Okay. Anything is starting with B? No. Anything is starting with AB? Yes, it is starting with AB. AB determines C. But we have already written C here, so we don't have to repeat it again. Anything is starting with AB? AC? Anything is starting with AC? No, nothing is there. Okay. Now anything is starting with D? Yes, here D determines E. So we have E. We can add E also here. Okay, E. Clear? So the D closure, the value of D closure is DACBE. Okay, DACEB. Okay. Now we have to check this RHS AE is available in this D closure. Yes, it is available. A and E is available here. Okay, so we can write that D closure includes A and E. Okay, so D closure includes A and E. So for these two set of functional dependencies, the condition is satisfied. Okay, A closure includes B and C, D closure includes A and E. So we can say that E covers F. Okay, so E covers F. So E covers F is satisfied. Clear? Next we are going to compute F covers E. Okay, F covers E. So what we have to take? F covers E means the second one is E. So E ode functional dependency we will try to derive it from F. Okay. So we will take the each and every functional dependency of E. Okay, first we take A determines B. A determines B. Okay. Now we will find the closure of A. What is closure of A? A closure, A plus equal to what? Okay. So which functional dependency set we will refer? We will refer to this instead of this one. That is the property. Okay, ഇതെന്നാണ് നമ്മൾ ഡിറൈവ് ചെയ്യാൻ പോകുന്നത്. We are going to derive this closure from this one, this functional dependency sets. Okay. So A closure. So anything is starting with A. So A closure, the first value will be A itself. Okay, no confusion. So first value will be A. Then the second value, so anything is starting with A. Yes, A determine BC. So BC can be written here. Okay, anything is starting with B? No. Anything is starting with C? Nothing is there. So A closure will be ABC. So whether this ABC contains the RHS of A determine B? Yes, B is there. So we can say that A closure includes this RHS B. Okay, so this is satisfied. Next we will take the next functional dependency, AB determines C. We take AB determines C. Find the closure, AB closure. AB closure, the first value will be AB. Okay, first value will be AB. Then we will check. Here whether anything is starting with A. Yes, it is A determine BC. Okay, so we will write BC here. So B is already here, so we will just write C. So anything is starting with D here? No. Okay, so ABC is the answer. ABC is the answer. Whether this ABC contains the RHS of this AB determine C? Yes. C ഇവിടെ ഉണ്ട്. So AB closure includes C. Okay, so these two are functions. Next functional dependency is D determine AC. Okay, so D determine AC. So we will find the closure of LHS, that is D closure. So the closure, the first value is D itself. Okay, now we will look into here whether anything is starting with D. Yes, AE. So we write AE. So anything is starting with A. Yes, BC is starting. B is A determine BC. Okay, so we can write BC. Clear? So the answer is this one, A D A E B C. Now we will look whether this D A E B E B C is having the RHS of this one. Yes. So that means that D closure includes A and C. Look, A and C is available here. So D closure includes A and C. Next to the last one, D determines E. D determines E. We will again compute the D closure. The first value is D. Okay. Now we will look, anything is starting with D. Yes, AE is there. Okay. Anything is starting with A. Yes, BC is there. A determine BC is there. So we will write BC here. Clear? So this D closure also contains this RHS E. Okay, E ഇവിടെ ഉണ്ട്. Clear? So all these functional dependencies of E is inferred from F. Okay, so we can say that E covers F. This is how we compute the E covers F and F covers E. So since E covers F and F covers E, we can say that E is equivalent to F. Clear? So if any one of this condition is not becoming true, then we don't have to proceed further. We can directly say that the E is not equivalent to F. Okay, suppose we have all the conditions are satisfied here. Okay, here we started with the first functional dependency and this condition is not satisfied here. This condition is not satisfied here means the closure does not contain the LHS of this. അങ്ങനെ ഒരു കണ്ടീഷൻ പറയുകയാണെങ്കിൽ we don't have to go further. We can stop here and conclude that E is not equivalent to F. Okay, this is one example. Now another example. Check X is equivalent to Y. Okay, അപ്പോൾ ഇങ്ങനെയായിരിക്കും ക്വസ്റ്റ്യൻ വരുന്നത്. X is equivalent to Y. So given X equal to A determines B. Okay, അപ്പോൾ ഈ സെറ്റിനകത്ത് ഒരു ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി ഉള്ളൂ. ഇൻ ദിസ് സെറ്റ് എക്സ് വി ആർ ഹാവിംഗ് ഓൺലി വൺ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി. നൗ അനദർ സെറ്റ് വൈ വി ആർ ഹാവിംഗ് ത്രീ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസീസ്. എ ഡിറ്റർമൈൻസ് വൈ, ബി ഡിറ്റർമൈൻസ് സി ആൻഡ് എ ഡിറ്റർമൈൻസ് സി. Okay, so we have to compute whether x is equivalent to y, not equal to. It is x is equivalent. We are going to draw three lines. Okay, x is equivalent to y. So we have to compute what? We have to compute x covers y. X covers y and y covers x. X covers y and y covers x we have to compute. Okay, so first I am going to compute x covers y. Okay, again I am rewriting the x and y functional dependency sets. X is A determines y, y is this one. Okay, so x covers y means ഞാൻ എന്താ എടുക്കേണ്ടത്? x covers y means I have to take the functional dependencies of y and that has to be derived from x. So what are the functional dependencies of y? We are having 3 functional dependencies. First of all, I will take A determines B. Okay, A determines B. I will take the closure of LHS. What is the closure of A plus? The first value is A. Okay, first value is A. Then I will check with this functional dependency x. Okay, A is start ചെയ്തെങ്കിലുണ്ടോ? Yes, A is determining B. So we can write B here. So A and B are the only attributes here. Clear? So this B is actually the RHS of this one. Okay, RHS of idana. അതുകൊണ്ട് A closure includes B. The condition is satisfied. Okay, so A closure is containing this B. So we can say this is true. Now next functional dependency, B determines C. I will take B determines C, apply the same closure, B closure, which is B. Okay, so anything is starting with B here? No. So only the value here is B. Okay, so this B, this set is not having the value C. ഇവിടെ C ഉണ്ടോ? ഇല്ല, it is not having the value C. Okay, so B plus does not include C. Okay, B plus does not include C. So this condition is not satisfied. So x covers will not covers y, or x covers y is not satisfied. Okay, ഇത് വെച്ച് തന്നെ സ്റ്റോപ്പ് ചെയ്യാം. ഞാൻ വെറുതെ ഇതിവിടെ കമ്പ്യൂട്ട് ചെയ്തേ ഉള്ളൂ. Okay, I just tried this one also. Okay, by looking at this condition itself, we can stop here and conclude that x is not equivalent to y. Okay, I simply calculated this also. A determines C. Find the A closure. A closure first value is A. If anything is starting with A, yes, A determines B. So B is also here. So A closure. So whether this A closure includes C? No. A closure does not contain the value C or the attribute C. So A closure does not include C. Okay, since these two functional dependencies does not include the RHS, we can say that x is not covering y, or x covers y is not valid. So x and y are not equivalent. So here we can conclude that x and y is not equivalent. Okay, so by looking at this condition itself, you can stop here. You don't have to compute y covers x. Okay, that is a waste of time. So we can stop here and conclude that they are not equivalent. X and y is not equivalent. Clear? So this is the concept of equivalence of functional dependencies. How can we say that two functional dependency sets are equivalent? Okay, it is not functional dependency, it is functional dependency sets. This is one set, this is another set. Okay, so our task is to check whether these two functional dependency sets are equivalent or not. For that, we have to check whether x covers y and y covers x. If both are true, then we can say that these two functional dependency sets are equivalent. Okay, അപ്പോൾ ഇതുപോലത്തെ ക്വസ്റ്റ്യൻസ് യൂണിവേഴ്സിറ്റിയിൽ ചോദിച്ചിട്ടുമുണ്ട്. Okay, next topic we are going to cover is minimal cover. So what do you mean by minimal cover? So minimal cover is nothing but we are just in a set of functional dependencies, some of the functional dependencies will be redundant or repeating. So such a functional dependencies will be creating actually extra space in our database. So what we do is we will eradicate those erroneous attributes or functional dependencies. So redundant functional dependencies will be removed. Okay, such activity is performed in minimal cover. Clear? If a functional dependency f is given, then f dash is the minimal cover. F dash is the minimal cover of this functional dependency set. If f dash does not have, there are two conditions. What? Redundant attribute. Okay, f dash should not have any redundant attribute. Okay, and also f dash should not have any redundant functional dependency. Okay, redundant ആയിട്ടുള്ള attribute വരാൻ പാടില്ല, redundant ആയിട്ടുള്ള functional dependencies വരാൻ പാടില്ല. Okay, so a minimal cover of a functional dependency set f is nothing but if it follows these two conditions. That what are the condition? If the minimal cover does not contain redundant attributes, and the minimal cover also does not contain redundant functional dependency. Okay, clear? Now how to compute this minimal cover? That is our next task. Okay. We are having 3 steps to compute this minimal cover. Okay, set of functional dependency എന്ന് നമ്മൾ റിപ്പീറ്റിംഗ് ആയിട്ടുള്ള അല്ലെ എലിമിനേറ്റ് ചെയ്യാനുള്ള 3 സ്റ്റെപ്സ് ആണ്. ഓക്കെ, സോ ദീസ് ആർ ദ സ്റ്റെപ്സ്. ഫസ്റ്റ് സ്റ്റെപ്പ്, ഇൻ എവരി ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി ദ റൈറ്റ് ഹാൻഡ് സൈഡ് must contain only single attribute. Okay, so we must confirm that the RHS of a functional dependency must contain only single attribute. ഇവിടെ നോക്കിക്കേ, A determine BC. Here we are having 2 attributes B and C. അങ്ങനെ വരാൻ പാടില്ല. That has to be eliminated. How we can eliminate that? We have already studied the previous inference rules. Inference rules, 6 inference rules we have already studied. In that we have studied about the decomposition rule. What is decomposition rule? Decomposition rule is the splitting of the attributes in the RHS. RHS-ലുള്ള attributes-നെ നമുക്ക് സ്പ്ലിറ്റ് ചെയ്യാനുള്ള മെത്തേഡാണ് decomposition rule. So A determine BC can be splitted like this: A determine B and A determine C. Okay, so in this manner we will eliminate the multiple attributes in the RHS of the functional dependency. Functional dependency RHS-ൽ ഈ പോലത്തെ മൾട്ടിപ്പിൾ ആട്രിബ്യൂട്ട്സിന് നമ്മൾ ഈ രീതിയിൽ എലിമിനേറ്റ് ചെയ്യാൻ പറ്റും. ക്ലിയർ? സെക്കൻഡ് സ്റ്റെപ്പ്, ഇതിൽ നമ്മൾ RHS-ലുള്ള മൾട്ടിപ്പിൾ ആട്രിബ്യൂട്ട്സിനെയാണ് എലിമിനേറ്റ് ചെയ്തത്. നെക്സ്റ്റ് വി ആർ ഗോയിങ് ടു എലിമിനേറ്റ് LHS-ലുള്ള multiple attributes. Okay, if the LHS is also having multiple attribute, that must also be removed. That is the second step stage. Second step, we are having 2 subdivisions. In the first subdivision, it is saying that if the LHS is also containing multiple attribute, that must be eliminated. Okay, that is the first one. 2a, step 2a. If functional dependency has multiple attributes on LHS, so remove that extraneous or redundant attributes. So those attributes need to be removed. How to remove, we will explain. Okay, second step, second part. If there is any trivial functional dependency, that can be removed. What do you mean by trivial functional dependency? So trivial functional dependency means the RHS is actually the subset of LHS. അതായത് if RHS and LHS is having some attributes in common, such functional dependencies are called what? Trivial functional dependency. We have already discussed the trivial and non-trivial functional dependencies in the last session. Okay, but trivial functional dependency എന്ന് പറഞ്ഞാൽ ഒന്നുമല്ല, RHS and the LHS will be having some attributes in common. Here we are having B in common, അല്ലേ? ഇവിടെ B common ആണ്, രണ്ടിലും common ആണ്. Okay, so AB determines B is trivial. Okay, since RHS and LHS have attributes in common. Clear? So this is called what? This is actually, this must be this, such functional dependency must be removed. Okay, that is what explained in the second step. Clear? So first step il endha parayunnathu? First step il, if RHS is having multiple attribute, that must be removed. Second step, first subdivision എന്താ പറയുന്നത്? If LHS is having multiple attributes, that must be removed. And also, if the functional dependency is trivial, that must also be removed. Okay. Now third step, remove the redundant functional dependency by using transitive rule. We have already studied about the transitive rule. Okay, IR3 transitive rule. Okay, in the inference rule. Okay, അതൊക്കെ നമ്മൾ പറഞ്ഞായിരുന്നു. അപ്പോൾ അങ്ങനെ ട്രാൻസിറ്റിവിറ്റി റൂൾ വെച്ചിട്ട് നമുക്ക് ഏതെങ്കിലും ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി എലിമിനേറ്റ് ചെയ്യാൻ പറ്റുമെങ്കിൽ അതങ്ങനെ ചെയ്യാം. Okay, so B determine A, D determine A, B determine D. So here, look here. So here B determines D and D determines A. B determines D, okay, and D determines A. But B determines D. RHS, ഇതിൻ്റെ RHS ഇതിൻ്റെ LHS സെയിം അല്ലേ? The RHS of this functional dependency and LHS of this functional dependency is same. In that case, we can write B directly determines A. We can directly write B determines A. That is the transitive rule. Okay, so B determines A in the variant is already there. So this must be eliminated. This can be eliminated. Okay, but transitive dependency vary namukku idupole kittuna inference ivide undengil that can be removed. Clear? So by using the transitive rule, the B determine D and D determine A, we can derive B determine A. Hence B determine A is redundant and can be removed. So B determine A is what? It is an extraneous functional dependency and that can be removed. Okay. So these are the three steps by which we can compute the minimal cover. Minimal cover means we are reducing the extraneous or the redundant functional dependencies or attributes. Clear? So it will be more clear when I explain it using an example. This is the first example. Let the given set of functional dependency set. So here they will be given only one functional dependency. The set E equal to B determines A determines D, AB determines D. Okay. So the first task is, if there is any multiple attribute in the RHS, ഈ ഓരോ functional dependency ഒന്ന് check ചെയ്യുക. Okay. ഈ ഓരോ functional dependency, we are having three functional dependencies. Okay. In these three functional dependencies, you check whether the RHS of these functional dependencies is having multiple attribute. No. Here it is having only single attribute. Here also single. Here also single. Okay. So first step we don't have to do any operation. Okay. We don't have to do any operation. The first step, this can be directly given to second step. Okay. Check if RHS, first step endana, check if RHS of functional dependency contains only single attribute. Okay. So here all the dependencies, all the functional dependencies have only one attribute on the RHS. So we have completed step 1. Okay. So we don't have to do any operation in step 1, we have completed step 1. Okay. So after the step 1, again the functional dependency set will be like this. This will be the functional dependency set. Okay. In step 2, in this completed functional dependency after step 1, we are going to apply step 2. Clear? What is step 2? Step 2 is, if there is any multiple attribute in the LHS, LHS multiple attributes undo, but AB, this is LHS, this is having multiple attributes. So we have to remove this one. How to remove? That is what we are going to explain here. Check if LHS of the functional dependency has only a single attribute. So here AB determines D is having what? Two attributes on the LHS. Clear? So how can we replace it? So this AB determines D means that AB is actually determining D. That means that if B, whether you check whether this B is determining D and also A is determining D is available in the functional dependency set. അതായത് എ ബി രണ്ടും കൂടെ ചേർന്നാണ് ഡിയെ ഡിറ്റർമൈൻ ചെയ്യുന്നത്. ഓക്കെ, അപ്പോൾ നിങ്ങൾ എന്ത് ചെക്ക് ചെയ്യണം? ആ ഗിവൺ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി സെറ്റിൽ ഇത് സെപ്പറേറ്റ് ആയിട്ട് ഡിറ്റർമൈൻ ചെയ്യുന്നുണ്ടോ എന്ന് ചെക്ക് ചെയ്യുക. അതായത് എ ഡിറ്റർമൈൻ ഡി, വെദർ ദിസ് എ ഡിറ്റർമൈനിങ് ഡി ആൻഡ് ബി ഡിറ്റർമൈൻസ് ഡി ഈസ് അവൈലബിൾ ഇൻ ദിസ് ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി. അതാണ് ചോദിക്കുന്നത്. ചെക്ക് വെദർ ഇറ്റ് ഈസ് വെദർ ബി ഡിറ്റർമൈൻസ് ഡി ഓർ എ ഡിറ്റർമൈൻസ് ഡി ഈസ് അവൈലബിൾ. യു ചെക്ക്. സോ ഹിയർ എ ഡിറ്റർമൈൻസ് ഡി ഈസ് ദർ അല്ലേ? എ ഡിറ്റർമൈൻസ് ഡി ഇവിടെ ഉണ്ട് അല്ലേ? എ ഡിറ്റർമൈൻസ് ഡി ഇവിടെ ഉണ്ട്. Clear? But B determines D is not there. B determines D is not there. So what we can do? We can replace this AB determines D by B determines D. Okay, so we can eliminate this AB determines D by what? B determines D. Clear? A determines D ഇവിടെ already ഉണ്ട്, അത് നമ്മൾ ചെയ്യണ്ട. So we can only pending is B determine D. So we can replace this AB determine D by B determine D. Okay, so we can So they are asking that AB determined D had two attribute analysis. Check whether it can be replaced by B determined D or A determined D. Already A determined D is there. Okay, so this A determined D is already there. It is redundant and will not be considered. So AB determined D may be replaced by what? B determined D. Okay, so this attribute, so this set functional dependency, in this functional dependency, what is the modification we have done? The third functional dependency. That AB determined D is replaced with what? B determined D. Okay, so this is the resultant functional dependency set after what? After step 2. Okay, now step 3, we have to apply step 3 in this one. Step 3 എന്താണ്? We have to remove redundant functional dependency using transitive rule. Whether we can apply transitive rule here, you just check. Here we can apply. Look here. B determine A and A determine D. What is the implication? This transitive apply ചെയ്യാൻ പറ്റുമല്ലോ. B determine A and A determine D, which means that B determines D. B determines D. Clear? So this is transitive rule. So this B determine D can be eliminated. Okay, this is venda because this can be implied from this two functional dependency. So this is redundant. This can be removed. So B determine D can be removed. Clear? That is step 3. Okay, step 3 adana. Remove redundant functional dependency by using transitive rule. By using the transitive rule, B determines A and A determines D, we can derive B determines D. B determines A determines D, we can say B determines D. Hence B determines D is redundant. Redundant is already available here, so that will be repeating. So that can be removed. So the minimal cover. So after removing all these things, after the 3 steps, the minimal functional dependency or the minimal cover will be B determines A and A determines D. This is the answer. Okay, this is how you have to derive step by step. Clear? Now let us see one more question, which is a university question. Okay, example 2. Find the minimal cover. A determines B, BC determines B, D determines ABC, AC determines D. Find the minimal cover. So first step is what? We have to look at the RHS, whether the RHS is having multiple attributes. If so, we have to remove those multiple attributes. Yeah, it is having multiple attributes A, B, C. Okay, so that has to be removed by decomposition rule. D determines ABC can be written as D determines A, that is one functional dependency. D determines B, that is another one. D determines C, that is another one. Okay, A determines B, C determines B, D determines A, D determines A. Next D determines B, D determines B, D determines C, D determines C. Okay, so this is the first step. Now AC determines D, that is copied here. So this is the result after step 1. This is the result after step 1. Clear? Next is step 2. Step 2, what is the step 2? The step 2, we have to check whether any multiple attributes are available in the LHS. Is there any multiple attributes available in LHS? Here it is not available. Here no, here no, here no, here no. Yeah, here it is there. Okay, is in this AC determines D, we are having multiple attributes in the LHS. Okay, so what we have to check, whether we need to check whether this AC is determining D. So you just need to check whether A is determining D. അങ്ങനെ ഒരു attribute, അങ്ങനെ ഒരു functional dependency ഉണ്ടോ എന്നുള്ളത് ചെക്ക് ചെയ്യുക. And also C determining D. Okay, ഇങ്ങനെ ഏതെങ്കിലും രണ്ടെണ്ണം ഇവിടെ ഉണ്ടോ എന്നുള്ളത് നോക്കുക. ഉണ്ടോ? A determining D, A determines D ഇല്ല. C determines D, C determines D ഉണ്ടോ? ഇല്ല, ഇത് രണ്ടും ഇല്ല. Okay, so we cannot remove anything here. Okay, so we cannot remove anything here. So this must be retained. ഇതിലൊന്നും ചെയ്യാൻ പറ്റില്ല. ഓക്കെ, ഇപ്പോൾ ഇതിൽ ഏതെങ്കിലും ഒരെണ്ണം ഉണ്ടായിരുന്നെങ്കിൽ, ഇഫ് സി ഡിറ്റർമൈൻ ഡി ഉണ്ടായിരുന്നെങ്കിൽ, ഇഫ് സി ഡിറ്റർമൈൻ ഡി വാസ് ഹിയർ, ഇറ്റ് വാസ് അവൈലബിൾ ഹിയർ, വി വുഡ് ഹാവ് റീപ്ലേസ്ഡ് ദിസ് എ സി ഡിറ്റർമൈൻ ഡി വിത്ത് എ ഡിറ്റർമൈൻ ഡി. Okay, so here we cannot do anything. So we will place this as it is without any change. So AC determined D will be retained. Okay, so that is what explained in the step 2. In step 2, AC determined D. There is no functional dependency with the A determined D or C determined D. So AC determined D must be retained. We cannot eliminate this. ഓക്കെ, ഇങ്ങനെ കണ്ടീഷൻസ് വരാം, നമുക്ക് എലിമിനേറ്റ് ചെയ്യാൻ പറ്റാത്ത രീതിയിലുള്ള കണ്ടീഷൻസ് വരാം. ഓക്കെ, നെക്സ്റ്റ് സ്റ്റെപ്പ് 3. സ്റ്റെപ്പ് 3ൽ നോക്ക്, ദിസ് ഈസ് ദ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി ആഫ്റ്റർ സ്റ്റെപ്പ് 2. ക്ലിയർ? അതിൽ ട്രാൻസിറ്റീവ് റൂൾ അപ്ലൈ ചെയ്യാൻ പറ്റുമോ? യാ, ഹിയർ വി ക്യാൻ അപ്ലൈ ഡി ഡിറ്റർമൈൻസ് എ ആൻഡ് എ ഡിറ്റർമൈൻ ബി. ഡി ഡിറ്റർമൈൻ എ ആൻഡ് എ ഡിറ്റർമൈൻ ബി. ഇറ്റ് ഇംപ്ലൈസ് ദാറ്റ് ഡി ഡിറ്റർമൈൻ ബി. Okay, here we have D determine B, that can be eliminated. D determines A and A determines B. Here we are having D determine B. So D determine A and A determine B is actually, it is actually D determine B. D determine B is the answer. So that is here. So that can be eliminated by using the transitive rule. D determines A and A determines A implies D determine B, which is available here. It is redundant and can be removed. So this can be removed and the final result will be like this. This is the minimal cover. A determines B, C determines B, D determines B, D determines C, AC determines D. Okay, അപ്പോൾ ഇതിലാണ് ട്രാൻസിറ്റീവ് നമ്മൾ അപ്ലൈ. ഇതിൽ വേറെ ഏതെങ്കിലും ട്രാൻസിറ്റീവ് അപ്ലൈ ചെയ്യാൻ പറ്റുമോ? യു ജസ്റ്റ് ചെക്ക്. D determines C, C determines B, again D determines B. Okay, അതും സെയിം റിപ്പീറ്റിംഗ് ആണ്. ഓക്കെ, സോ നോ മോർ ട്രാൻസിറ്റീവ് ക്യാൻ ബി അപ്ലൈഡ് ഹിയർ. ഇഫ് എനി മോർ ട്രാൻസിറ്റീവ് റൂൾ ക്യാൻ ബി അപ്ലൈഡ്, യു ക്യാൻ ഡു ഇറ്റ്. ഓക്കെ, സോ ദിസ് ഈസ് ദ മിനിമൽ കവർ. ക്ലിയർ? ദിസ് ഈസ് അനദർ യൂണിവേഴ്സിറ്റി ക്വസ്റ്റ്യൻ. വൺ മോർ. F equal to AB determine C, C determine AB, B determine C, AB determine AC, and this one. Okay, find the minimal cover. So first, what is the first step? We have to remove മൾട്ടിപ്പിൾ ആട്രിബ്യൂട്ട്സ് ഫ്രം RHS. അങ്ങനെ ഏതെങ്കിലും ഉണ്ടോ? യെസ്, ഉണ്ട്. ഇവിടെയുണ്ട്. ദാറ്റ് ഹാസ് ടു ബി റിമൂവ്ഡ്. ഓക്കെ, ദാറ്റ് ഹാസ് ടു ബി റിമൂവ്ഡ്. സോ റിമൂവ് മൾട്ടിപ്പിൾ ആട്രിബ്യൂട്ട് ഫ്രം RHS. സോ വി ഹാവ് റിമൂവ്ഡ് എ ബി ഡിറ്റർമൈൻ സി. അതുപോലെ എഴുതും. ദിസ് ക്യാൻ ബി റിട്ടൺ as സി ഡിറ്റർമൈൻ എ, അല്ലേ? സി ഡിറ്റർമൈൻ എ ആൻഡ് സി ഡിറ്റർമൈൻ ബി. ദിസ് ഈസ് റിട്ടൺ as സി ഡിറ്റർമൈൻ എ ആൻഡ് സി ഡിറ്റർമൈൻ ബി. ഓക്കെ, ബി ഡിറ്റർമൈൻ സി. അതുപോലെ എഴുതി. എ ബി ഡിറ്റർമൈൻ എ സി. ABC determines AC. That can be written as ABC determine A, ABC determine C. Okay. Next, A determine C. അതുപോലെ എഴുതി AC determine B. So this is the reduction after step 1. Okay. Now in step 2, what is the thing? Remove the multiple attribute from RHS. RHS ഏതെങ്കിലും LHS multiple attributes ഉണ്ടോ? Yes, here it is having. Here it is having. Okay, here it is having. But here you just look. So which all states we are having, which all functional dependencies are having multiple attributes in LHS? This one and this one. Okay, so before going into the reduction, in the step 2 is having, we have already studied that the step 2 is having two conditions. What? Step 2 is having two conditions. First we have to check whether RHS is having, LHS is having multiple attributes, and also what? If the functional dependency is trivial, we can remove it. Okay, trivial ആണെങ്കിലും റിമൂവ് ചെയ്യാൻ പറ്റും. ഓക്കെ, അപ്പോൾ അത് നമ്മളിവിടെ ചെക്ക് ചെയ്യണം, വെദർ എനി ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി ഈസ് ട്രിവിയൽ. സോ ലുക്ക് ഹിയർ. This one is not trivial, this is trivial. How we can say that this is trivial? Because this RHS and LHS is having some attribute in common. So A is common. Here also C is common. Okay, what about this this is not having anything common. Okay, so we can remove this functional dependency and this functional dependency due to, since it is trivial. Okay, so this is the case. So here they have removed ABC determines A and ABC determines C because they are trivial. Okay, ഇനി അടുത്തത് നമുക്ക് ചെയ്യാൻ പറ്റുന്ന ഇതാണ് എ ബി ഡിറ്റർമൈൻസ് സി. എ ബി ഡിറ്റർമൈൻസ് സിയിൽ you check whether we are having a functional dependency called A determines C or B determines C. ഇത് ഇവിടെ ഉണ്ടോ നോക്കുക. A determines C ഉണ്ടോ? Yeah, A determines C is there. B determines C ഉണ്ടോ? Yes, B determines C ഉണ്ട്. ഓക്കെ, അതുകൊണ്ട് നമുക്ക് ഇതിവിടെ നിന്ന് എലിമിനേറ്റ് ചെയ്യാം. സോ ദിസ് ക്യാൻ ബി റിമൂവ്ഡ്. ഓക്കെ, ബിക്കോസ് ഇതിൻ്റെ ഇംപ്ലിക്കേഷൻസ് രണ്ടും ഇവിടെ ഉണ്ട്. AB is determining C. That means that individual attribute must determine C. AB determines C means A must determine C and B also must determine C. Okay, ആ രണ്ട് കേസും ഇവിടെ ഉണ്ട്. So this AB determines C can be removed. Clear? Next case AC determines B. You just check whether A determines B ഉണ്ടോ and C determines B ഉണ്ടോ. Okay, AC determines B. So there exists A determines B illa, but we are having C determines B. Okay, C determines B ഉണ്ട്, but A determines B ഉണ്ടോ? ഇല്ല, A determines B ഇല്ല. So we can replace this AC determines B by A determines B. Okay, so AC determines B can be replaced by A determines B. Why? Because we are only having C determines B. ഓക്കെ, ഇവിടെ സി ഡിറ്റർമൈൻസ് ബി ഉള്ളതുകൊണ്ട് നമുക്കിനി വേണ്ടതാണ് എ ഡിറ്റർമൈൻസ് ബി മാത്രമാണ്. ഓക്കെ, അത് വെച്ച് നമുക്ക് റീപ്ലേസ് ചെയ്യാം. ഓക്കെ, സോ ആഫ്റ്റർ ഓൾ ദിസ് റീപ്ലേസ്മെൻറ്റ് ദ ഫൈനൽ the implications and the functional dependency after the step 2 will be like this. C determines A. Okay, so this is replaced. C determines A, C determines B, B determines C, A determines C and A determines B. Okay, now step 3. In step 3, what we have to do is we are applying transitive rule, അല്ലേ? Transitive rule. ഇപ്പോൾ transitive rule apply ചെയ്യാൻ പറ്റുന്ന ഏതൊക്കെ functional dependency ഉണ്ട്? Look here, A to C and A determines C and C determines B. Okay, ഇവിടെ നമ്മൾ അപ്ലൈ ചെയ്യുമ്പോൾ എന്ത് കിട്ടുന്നു? A determines C, C determines B. That means that A determines B. Whether we are having A determine B? Yes, we are having A determine B. Okay, so these two can be replaced with this. So A determine B can be replaced. It can be eliminated. Remove this A determine B and we have written the minimal cover. Okay, ഇവിടെ C determines A, C determines B, അത് എഴുതി, B determines C എഴുതി, A determines C, A determines B നമ്മൾ റിമൂവ് ചെയ്ത് കളഞ്ഞു. Okay, so this is the minimal cover. So always remember that in step 2 we have to check two conditions. Whether it is trivial ആണെങ്കിൽ റിമൂവ് ചെയ്യാം, ആൻഡ് ഓൾസോ ദ LHS is having any multiple attributes. Okay, so these two questions are very very important questions. It will be a sure question in university, like what minimal cover and functional dependency equivalence of functional dependency sets. These are very important. Okay, so we will discuss more university questions in the during our revision classes. Okay, so please go through these problems and do it. Thank you.